Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all hydrostatic pressure and its application. So this is the 15th lesson of your grade 10 science textbook, and as you all know it is a physics lesson. When we say hydrostatic pressure, normally hydro is a term that is related to water, and you all know water is a liquid. So here we are going to discuss the pressure exerted by liquids. Hydro. Why do we say static? Normally liquids can flow, water can flow. At the same time, the water can remain still. So usually the pressure is exerted by a liquid when it is still or static. That is why we call it hydrostatic pressure. Not that the water flows does not exert pressure, but here we are going to consider the instances where the liquid is still. So hydrostatic pressure and its applications. So how we can use this hydrostatic pressure in our day-to-day life. So when we say hydrostatic pressure, we are not only going to focus on pressure exerted by liquids. We will start off with the pressure exerted by solids, and then we will discuss the pressure exerted by liquids, and thereafter pressure exerted by gases as well. So with that introduction, students, we will look at the contents of the lesson. Hydrostatic pressure and its application. So that's unit 15, physics lesson. The first topic is going to be pressure. You all are familiar with pressure. You all know what that is. You have learnt about pressure, the factors that affect pressure and the units of pressure. So we will look at it again under the topic pressure. Then we will discuss hydrostatic pressure. So as I told you all, the pressure exerted by liquids and how that can be used. Then transmission of pressure through liquids. So there are systems where we use the liquid pressure and the transmission of pressure for our advantage. So that is what we discuss under transmission of pressure through liquids. Then the last topic will be pressure due to gases. So like liquids, gases also exert pressure. So we will be discussing that type of pressure, and we will see how we can measure the atmospheric pressure. So those are the contents of the lesson, students. With that introduction, we will move on to the lesson. So pressure. This is the pressure that you have already learned. Now let's consider a solid substance, an object. Let's say imagine a book kept on a table or a very heavy block of wood kept on a table. So this particular block will have a surface area. That is what is denoted as A, surface area. Surface area. Then F is what? Now you all know any object has a mass and there is the gravitational acceleration. You are familiar with that. Mass into gravitational acceleration is the weight. Always the weight acts downwards. So weight is a force. So here this is the force exerted by the object due to its mass or the weight of the object acting downwards. Now this weight is spread throughout this area. Because of that, it exerts a pressure. And you all know the definition of pressure. What is it? Force exerted over a unit area. So if I define pressure first, force exerted over a unit area. So this is the definition, is known as pressure. You all are familiar with this definition and you all have to remember this. So force exerted over a unit area is the pressure. If we write the equation for pressure, so if we write the definition, using the definition, if we write the equation, we can say pressure instead of saying force, we can say perpendicular force. Perpendicular force exerted. Why do we say perpendicular force exerted? Because always it acts downwards. Normally you have the surface and the force will be perpendicular to that. That is why we say perpendicular force exerted divided by the surface area. So this is again the equation that you all need to remember, students. Equation for pressure. Pressure exerted by solids. So if we consider the mass of an object as, let's say, 10 kilograms. So you all know the weight will be 10 into gravitational acceleration, that will become 10 into 10, 100 newtons. So if this 100 Newton force is spread over an area of 10 meters square, then you need to divide the force by area. Before going to that, we will look at the units for pressure. Now, when we say pressure, we can also use the symbols. Pressure is denoted by capital P, that you are familiar with that, and force F over surface area A. And this whole equation can be simplified and written as pressure equals force over area. So, when you are doing the calculation, students, you don't have to write the full equation. You can write this simple equation. Pressure equals force over area. Or you can use the symbols. P equals F over A. If we consider the units, now for force, what is the unit? It's going to be newtons divided by area. The standard unit is going to be meter square. So, what is the unit for pressure? Newton meter minus 2. But this is equal to the unit Pascal. To honor the scientist, Pascal. And the unit is written as PA. And this is the standard unit of pressure. Standard unit of pressure. So, if I go back again, students, you all can see, according to the diagram, an object exerts a weight on a surface, and that weight is spread across a area. So, based on that, if we define pressure, force exerted over a unit area is known as pressure. Based on this definition, if we write the equation, you can see pressure equals perpendicular force exerted divided by surface area. It has to be area, surface area, A-R-E-A, surface area. So, if you put that into an equation form, you can see here pressure equals force over area. We can use the symbols P equals F over A. From that, if we substitute the units, force is given in newtons, area is given in meter squared. So, you get the unit Newton meter minus 2. But that is equal to the unit for pressure, that is the standard unit for pressure, Pascal. Capital P and simple A. I am sure you are all familiar with this because you all have learned this in grade 9 as well. So, Pascal is the SI unit of pressure. And also, you all know about quantities. Normally, we divide all these quantities based on their magnitude and direction as vector quantities and scalar quantities. What are scalar quantities? Quantities that only have a magnitude. Whereas vector quantities, quantities that have a magnitude and a direction. So here, although the force is acting downwards, it spread over an area, that is for solids. But when we look at liquids, gases, you all know there is air around us. Now this air exerts a pressure. That's what we call as atmospheric pressure. Now that atmospheric pressure and the pressure exerted by liquids is in all directions. So therefore, pressure has a magnitude but no direction. So what quantity is that? It is a scalar quantity. So that is what we need to know after this. Pressure has magnitude but no direction. Therefore, it is a scalar quantity. Is that okay, student? So we have discussed the definition. Again, I will repeat. Force exerted over a unit area is pressure. So from that we get the equation pressure equals force over area. From there we derive the unit Newton meter minus 2, which is equal to Pascal. That's the standard unit of pressure, and pressure is a scalar quantity. So if we do an example, like I told you all before, now if there is a block placed on a table and let's say this has a weight of 100 Newton. So the force exerted is going to be 100 Newton. And if the surface area is, let's say, 5 meters square, the surface area that is in contact with the table. So if we calculate pressure, pressure is equal to force over area. That is going to be 100 newtons divided by 5 meters square. So when you divide, this becomes 20 Newton meter minus 2. That's going to be equal to 20 Pascal. So here, of course, students, since we substitute the unit, we can make sure that we have the substitution done correctly with the correct units. So it's easy for you all to check. And also, you get the unit Newton meter minus 2. You don't have to write that step again, but you can directly write the final answer as 20 Pascal. I have written those so that you will remember Newton meter minus 2 is equal to Pascal, equivalent unit, because they are the same. So, pressure is the force exerted over a unit area. This is how we calculate pressure. With that, students, I am sure you all can understand the calculation. We will look at some more examples. Example 1. This is a worked example given in your textbook, but still I will do it again. A cubic shaped box is placed on a table. If the weight of the box is 400 Newton, so here weight is 400 Newton, and the area of the bottom of the box is 0.2 meter squared. Find the pressure exerted on the surface of the table under the box. So here, of course, we have the table. On that, there is a block. So what is going to happen is this has a weight of 400 Newton. And the surface area is going to be 0.2 meter squared. This force will be exerted this way, perpendicular force. So that is going to exert the pressure. We are supposed to calculate the pressure. Pressure, as I told you all, we can just stick to the simple equation. Pressure equals force over area. But always, students, when you all are doing calculations, make sure that you write the equation, then show the substitution and finally get the answer. It is better if you can show the working as well. So here, force is given in the correct unit, 400 newtons. 400 newtons. And what is the area? 0.2 meter square. 0.2 meter square. So if you calculate, what will be the pressure? When you divide by 0.2, it becomes 2000 Newton meter minus 2. That is 2000 Pascal. 400 divided by 0.2. Is that okay, student? So as I told you again, you don't have to, this step is not a must. But for you all to remember, I am including that as well. So you can go from here to here. Substitute with the correct units, then write the final answer. 2000 Pascal. So with that, students, I'll move on to the next question. Example 2. The pressure exerted by a pile of soil distributed over an area of 8 meters squared of the ground is 150 Pascal. So here you can see they have given the area and they have given you the pressure exerted by the pile of soil. What is the force exerted on the ground due to the pile of soil? So again, you need to start with the equation. What is the equation? Pressure equals force over area. You can also use this, students. P equals F over A. That is also accepted. Pressure equals force over area. We can either rearrange now and substitute, or you can substitute and rearrange the equation. Both are fine. I will rearrange it first. We need to find the force. This is what we need to find. So if we rearrange, force will be equal to pressure into area. So what is the pressure? Pressure is given to us as 150 Pascal. 150 Pascal into area is what? 8 meter square. So in this also, you all know, students, Pascal is equal to Newton meter minus 2. So therefore, meter minus 2 and meter squared. So just to show that for the first time, I will substitute the unit Newton meter minus 2 into 8 meter square. So you all know the simplification. Meter minus 2 will cancel off with meter square. So you will be left with the unit Newton. That is the unit for force. So you are sure that you have done the calculation correctly. So here 150 into 8, you will get the value as 1200 newtons. That is the force exerted by the soil, pile of soil. So the pressure exerted by a pile of soil distributed over an area of 8 meters squared of the ground. So that is 150 Pascal. So the force exerted by the pile of soil is 1200 newtons, or the weight of the pile of soil is 1200 newton. So I am sure you all can understand these calculations clearly. So with that calculation, students, we have finished the pressure exerted by solids. So now I am going to move on to the next topic, that is hydrostatic pressure. Hydrostatic pressure. First look at the diagram, students. Now here this is something that I have already explained to you all. You are familiar with this. So when there is a solid matter or solid object, the force exerted is downwards and there is the area, force, area. So force divided by area is what we defined as pressure. Perpendicular force exerted over a unit area is what we defined as pressure. So you know the pressure exerted by solids. The same way, now if you take this glass of water, now the water has a mass, so obviously it has a weight. The weight of water will be acting downwards. So weight of water, weight of, I'll write it as liquid here, that is going to be the force exerted. And here you can see there is an area. This is the area. So similar to pressure exerted by solids, there is pressure exerted by liquids also. So there the weight acts downwards. So because of that, the pressure will be exerted over the bottom surface of the container. That is not the only pressure. Now this water, because the particles can move to a certain extent, same goes for gases also. They can exert pressure throughout the container, on the walls of the container as well. So there is pressure acting downwards, there is pressure acting towards this wall. So towards all the directions, there is pressure exerted by the liquid. That is the difference. Now in solids, always the weight acts downwards and the pressure is exerted downwards. But when you take the liquids, there is pressure exerted on the bottom surface of the container as well as pressure exerted on the walls of the container as well. You all have to remember that. So with that introduction, we will look at the explanation here. Hydrostatic pressure. Not only solids but liquids also exert pressure. So this is something you have to remember. Liquids also exert pressure. When we place a solid object on a table, like that example, a pressure is exerted on the table because of the force acting on the table due to the weight of the object spreads over the total contact area between the object and the table. That is what I explained to you all. So if you look at the area, that is the total contact area. And there is the weight of the block, that is the force acting downwards. So because the force spreads over that area, there is a pressure. You are familiar with these, students. We have discussed in your previous grades also the straps of the school bag. When you have a certain weight for the school bag and if you have a thin strap, because the area is less, the pressure you feel on your shoulders will be greater. Whereas when you have a broad strap, then the pressure will be less. So there force over area. We have discussed that relationship before. So the weight or the force spreads over the area. That is how the solids exert pressure. Similarly, a pressure is exerted on the bottom of a container. So this is something that I told you. Bottom of a container, because the force acting on the bottom of the container due to the weight of the liquid spreads over the bottom surface of the container. So what I explained. Now this is the area, weight of water spreads over this area. Because of that, there is pressure exerted. Is that clear to you all, students? I am sure you all can understand. So the pressure is exerted by the liquid not only on the bottom of the vessel. Not only on the bottom of the vessel. I explain this as the vertical walls, those are the side walls of the vessel will also experience the pressure. So liquids exert pressure on the bottom surface as well as the vertical walls. Apart from this, there are many more characteristics of pressure due to liquids. So not only this, now that is one difference between the pressure exerted by solids and pressure exerted by liquids. Not only that, there are many other characteristics. Hydrostatic pressure, that is the hydrostatic pressure exerted by liquids. Let us investigate these characteristics of hydrostatic pressure. So to understand how they exert pressure and also the factors that affect the hydrostatic pressure, we will discuss some activities so that you all get a good understanding of how liquids exert pressure. Not only on the surface, bottom surface of the container, but also the walls of the container, the vertical walls of the container. But if there is a top surface, there is no pressure. Why? Because the liquid is down, the top cover or the lid is on top. There's no way the liquid exerts pressure on the top surface. It is only the bottom surface and the vertical surfaces. Even if you take a water bottle, your drink bottle, even if you have your lids closed, but the base is kept on the table, then the liquid or the water that is inside your bottle will exert a pressure on the bottom surface and the vertical walls only, not on the lid. That you all have to understand, students. So with that, we will look at some activities and try to understand the characteristics of hydrostatic pressure. So the first activity demonstrate that pressure acts in all directions. So we already discussed that there is pressure acting on the bottom surface as well as the vertical walls. So we need to demonstrate that pressure acts in all directions. So here we need these two materials. We need a polythene bag or even a plastic bag. Polythene bag is more convenient. You can use a plastic bag also. And we need water. What we can do is we can take the water in a container, maybe a large glass tub or even a plastic bucket, plastic tub, anything is fine, where you can dip this polythene bag and fill it with water and you can lift the bag out. So before doing that, you need to make a few holes on this polythene bag or plastic bag. We'll look at the method. Make some holes in a polythene bag, fill it with water and hold it up. So you will have the polythene bag like this. You can make holes randomly here and there, all around the bag, in all directions and in all levels. And then we dip this bag into a bucket containing water and fill the bag with water. After that, when you lift the bag up, so if you have a handle, it's easy, or you have to hold it together and you need to lift the bag up. So if you don't have a handle, it will be something like this. You will be holding at this point. There are holes made randomly on all directions. Obviously, you all can guess the observation. What will happen? Water will exit through all these holes. You need to observe how they exit and whether they exit through all the holes. That is a very, very simple activity. Let us go to the lab and do this activity now. Okay, students. So now we will do this activity in order to understand the characteristics of hydrostatic pressure. So when we say hydrostatic pressure, the pressure exerted by liquids. So to understand the first characteristic, that is how pressure is exerted by the liquids, we are going to do this activity. So to do that, I have this polythene bag. In this, I have randomly made holes in all directions and at all levels. And also, I have a container to fill the colored water, and in this bucket, I have colored water. You all know the reason why we need to use colored water. You can just use normal water, but it's not clearly visible. So if we use colored water, you can see how it comes out through the or exits through the holes of the polythene bag. So now I am going to do the activity. You all need to observe closely how the colored water exits through the different holes. So we need to fill the bag. A polythene bag is ideal, but we should make sure we don't crush the bag. We just need to hold it up. So now that I have filled it, I will just lift it up. Now can you all see how water exits? From all different sides, I will turn the bag slowly. You can see. Can you all see, students? From all the holes, the water exits out, and look at the way it's coming out. You all can see a difference in the way it's exiting, but through all the holes, it exists. From all directions as well. all levels as well as all directions. And also you all can observe, students, when the amount of water decreases, the speed with which the water exits through the holes decreases. That is because the amount of water is less, but still you can see through all the holes water is exiting. So from that observation, what can we conclude? What can you all understand? Now I had holes throughout the bag at different levels and also in all different directions. So then from this we can conclude and say that pressure is exerted in all directions by the liquid. Here it is water, but by all liquids pressure is exerted in all different directions. Okay, students. So did you all get a good observation of what happens? How water exerted pressure? I am sure you all did. So there is a diagram that shows how water will exit from the polythene bag. How does it come out? It comes out in all directions and from all the sides with different forces. But you all were able to observe that they exit from all the different holes. So that is the observation. So here I will say water exits through all the holes in different directions and levels. So here you can see through these like that water comes out from all the holes. Water exits through all the holes. You can either write the observation as water exits because we used water, or you can commonly use the term liquid and say the liquid exits through all the holes. So from this observation, what can you conclude? Why does the water exit? Because there is a pressure being exerted by the water on the wall of the container. But when there is the hole, due to that pressure, water is pushed out. That is why water exits through the holes. Is that clear to you all? So here, since water exits through all the holes in all directions, we can conclude and say that the liquids exert pressure in all directions. So that is going to be our conclusion. The liquid exerts pressure in all directions. So here I'll explain it. There is water pressure, or we'll say there is pressure being exerted by water in all directions on the inner wall of the bag. When holes are present, the pressure pushes the water out. That is why water exits through the holes. And also we can say because the water exerts pressure in all directions, water exits through all the holes. So that is the explanation what I explained to you all before. So if we go back and look at the observation, that is the diagram, how water comes out. So water exits through all the holes in different directions and levels. So those are the holes in all sides as well as different levels. So from that, this is the conclusion. The liquid exerts pressure in all directions. So I told you all students, although we use water, we will come to a common conclusion where we consider all the liquids. So liquids exerts pressure in all directions. And this is the explanation. So there is pressure being exerted by water. Here I use the term water because that is what we used for the activity. By water in all directions on the inner wall of the bag. When holes are present, the pressure pushes the water out. Due to the pressure only, water is pushed out. That is why water exits through the holes. Because the water exerts pressure in all directions, water exits through all the holes. So if water doesn't exert pressure on the vertical walls, then the water will not come out or exit through the holes. It will only exit through the holes at the bottom surface. But here it exits through all the holes. So that means there is pressure on the bottom surface as well as the vertical walls of the container. Is that clear to you all students? I am sure it is. So with that, we'll look at another activity where we discuss some more properties or where we try to understand more properties of, more characteristics of hydrostatic pressure. The next activity, demonstrate that the pressure at the same level of a liquid is the same. So this is another characteristic. Demonstrate that the pressure at the same level of a liquid. So here we consider the level. Same level of a liquid is the same. So to do that, we need again two materials. We need a transparent, that is not a must, but it has to be a plastic bottle. If it is transparent, you can also look at the way the water level decreases and all that easily. But even if it is not a transparent bottle, it's okay. But it has to be a plastic bottle so that you can make holes. And to observe the change easily, what we will do is we will use colored water. Colored water. You can use the normal water, no problem. But if we make it colored, it's more clearly visible. So that is the purpose of using colored water. So you need a plastic bottle and you need water. So like we did before, you take water into a tub and you dip the bottle, open the lid, you dip the bottle inside. So the water will go into the bottle, it will get filled. And once the bottle is filled, we take it out and hold it at a certain height above the tub. So you can see, what can you see? So you all can observe that the water will exit through the holes, but observe how it exits. That's the important thing. So again, a simple activity. We will look at the method once more. Method, take a plastic bottle with a height of about 25 centimeters so that you have enough water. Make several holes at the same level near the bottom. So here of course you have the bottle. So here students, you all have to make holes at the same level and throughout the outer side. So in all directions, but it has to be the same level. That is very important. So same level. So thereafter you will be filling water and you will have to observe how water exits through these holes. That is the activity. So we are trying to demonstrate that the pressure exerted by the liquid at the same level is the same. So that is why you need to observe how the water exits. So a simple activity. Let's go to the lab and do this activity now. Okay, students. So now we will try to demonstrate another characteristic of hydrostatic pressure, that is pressure exerted by liquids. So we will demonstrate, or I will actually demonstrate to you all, that the pressure at the same level is the same value. So the pressure exerted by a liquid at the same level is the same in all directions. To do that, again we need to have colored water. Normal water is sufficient, but as I told you all before, when we have colored water, the visibility is better. And then I have this bottle, a plastic bottle. Here in this bottle, I have made all the holes at the same level in all different directions, but at the same level. That is the important thing. That is what we are going to observe now. Pressure exerted by liquids at the same level is the same. So then you all know the activity. We need to fill water into this. Once we fill it completely, then I can take it out of the water. Then you all need to observe how water exits through the holes. So now you will be able to see, you can see here students, how the water exits. Can you all see? It's coming out through all the holes, and as well you can see it's coming out with the same speed. All the holes are at the same level. You can see it exiting with the same speed. And again, you all can observe when the amount of water decreases, the speed decreases. That of course you all can understand. So from that observation, I am sure you all can understand that a liquid exerts the same amount of pressure at the same level in all different directions. Okay, students. So did you all observe how the water exited the bottle? I am sure you all did. You were able to see clearly when the water exits. Now the diagram is shown to you. From the outer line of the bottle. So when you all observe the horizontal distance, now if we take the bottom surface like this, the horizontal distance to which the water exits, if we measure all these distances, we don't have to really measure it, you all were able to observe it clearly. All these distances were the same. So here again, what is the reason? Now there is pressure being exerted by water. Due to that pressure, when there are holes, water is being pushed out through the holes. And when they are being pushed out with the same pressure, they travel the same distance. So that is why this horizontal distance is equal. But you were able to observe when the water level decreases. When the amount of water is less, it becomes closer and closer to the bottle. The horizontal distance decreases. But in the same manner, throughout the bottle, in all directions, the horizontal distance remains the same. So that means we can conclude and say that the liquids exert a pressure, equal pressure at the same level. The liquids exert equal pressure at the same level. Is that clear to you all, students? So then we will write the observation. Water exits through the holes in the same level with equal horizontal distance. So that is important. These distances from the bottle are the same. So in the diagram, it is shown how they come out in all directions, but you all were able to observe clearly that the distances, horizontal distances were the same. We don't have to do a measurement, but you can observe clearly. So from that, again we can conclude. What can we conclude? Pressure exerted by a liquid at the same level is the same. Pressure exerted by a liquid in the same level is the same. So that is how we can conclude from this activity. So if you are to explain this, what can you say? Liquid exerts a pressure and at the same level, it exerts the same amount of pressure in all directions. Because of that, the water is pushed out through the holes with the same pressure. That is why they travel the equal horizontal distance in all sides of the same level. So that is the explanation. So here I can say explanation. This is for you all to understand what happens, students. So the water exerts the same pressure in all directions at the same level. So this is important. We are looking at the same level. Therefore, water is pushed out with the same pressure through the holes in the same level. That is why the water exits with the same horizontal distance in all directions of the same level. Now I am repeating the term same level because that is what we are trying to understand here. You know that liquid exerts the pressure in all directions. That was the first activity. So here also it exerts the pressure in all direction but in the same level. So that is why water exits and travels the same horizontal distance. I am sure you all can understand that clearly. With that, students, we will move on to another activity. Activity: demonstrate the change in pressure with the depth of the liquid. So here we are going to observe how the pressure changes with depth of the liquid. So you all already know pressure is exerted in all directions and pressure at the same level is the same. So here the levels are different, that is why the depths are different. So again, to observe that, we need to have a plastic bottle, and we need water. So again, colored water would be better. Better to observe what happens. That's the only reason. You can just use normal water also. So we need the plastic bottle and water. But here, when we make the holes, we make holes with equal distances at different levels along one line. So here, we don't change the direction. We use the same line like this along the same line but at different levels so that the depth will change. Again, you insert it into a tub containing water. So the water will fill into the bottle, and when you take the bottle out and hold it at a certain height, you will see the water exiting. But here you have to observe again how the water exits the different holes. That is the activity. We will look at the method again and then do the activity. So the method: take a plastic bottle with a height of about 25 centimeters. So that is again to make all the holes with almost equal spaces. Make a set of approximately equally spaced holes from top to bottom of the plastic bottle. It can be from top to bottom or bottom to top. They need to have approximately equal spaces. You don't have to measure and make the holes. So then what do? We fill it with water, hold the bottle up and observe. So like before, you have the bottle. So here we need to make sure that we make the holes along the same line. Now if we take this surface, approximately equally spaced holes, then what you need to do is you need to fill it with water. How do we fill it with water? Immerse it into a tub containing water. So the water will fill into the bottle. Thereafter, you take the bottle out. So when you take the bottle out, obviously you all know water will exit through the holes. So what do you need to observe? The way they exit through the holes. So the horizontal distance travelled by the water or the speed with which water exits the holes. That is what you need to observe here. So I am sure it's a very simple activity. You all can understand the activity. We will go to the lab and do the activity now. Okay, students. So now another characteristic. Already you all know when we say hydrostatic pressure, pressure is exerted in all directions and in all levels. Then we saw that pressure at the same level is the same. Now I am going to demonstrate that the pressure changes with the depth of the liquid column or the water column. Or for that matter, we can understand that the pressure increases with the depth of the liquid column. So to do that, again I have the colored water. You all know the reason. It's more clear to observe how the water exits through the holes. And then I have this bottle here, a plastic bottle with holes at the same line, along the same line, but at different levels. So I'll be filling water into this and then you will have to observe how water exits through the different holes. We will have to fill water to the maximum. Now I will Can you all see, students, how water exits through the holes? Can you all see from the top, it comes out with less speed. But whereas from the bottom holes, it comes out with more faster. And also the distance to which the water is pushed out is longer from the bottom holes and shorter from the top holes. Can you all see here? This is more longer, this is shorter. So from this, now even here you can see this goes far, this is short. So from this observation, what can we conclude? Now we all can understand that the pressure at depth, or when the depth of the water increases, the pressure exerted by that water increases. So at the top the pressure was less. As we went down, as the holes go down, as the depth of the water increases, the pressure increases. That is why water is pushed out with higher pressure. So that's why it goes to a more longer distance. I am sure you all can understand that. So students, you all observe the way the water exited from the bottle. You all were able to see the force with or the speed with which the water exited the bottle, and also you were able to observe the horizontal distance. So you can see the diagram here. You can remember when they exited the bottle. The water that came out from the holes below, or the holes at the lower level of the bottle, they traveled a longer horizontal distance with a higher speed. They came out faster. So that's why they were pushed away as well. But when you go up, you were able to see the horizontal distance was less and also the speed was less. So when the depth of the hole became lower in the bottle, the speed with which the water was pushed out was more, and also they traveled a longer horizontal distance. So again, when the water level decreases, you were able to see the decrease in speed. That of course is not really relevant to the observation here, that you all know. When the amount of water is less, obviously the force will decrease. But here, initially when you observed, this is what you were able to see clearly. So from that, what can you say? Now water is exerting a pressure throughout this liquid column. Now here it exerts less pressure. That is why water comes out with less speed and travels less horizontal distance. But as you go down, it pushes the water with higher pressure. That is why water exits from here faster and also travels a longer distance. So as you go down, or we can say when depth increases, pressure exerted by water increases. So that is the explanation and the conclusion that you can get from this activity. So before I go to the conclusion, I'll write the observation. You can say water exits with higher speed from the holes at the lower level and with lesser speed through the holes at higher levels. we can say accordingly the horizontal distance changes. So those were the observations. Horizontal distance you can see is more when it is a hole towards the lower level. From the hole at the higher level, the horizontal distance is less. So that was our observation. From that, we can come to the conclusion. We can say the pressure exerted by liquids increase with the increase in the depth of the liquid column. Is that clear to all students? So as we go down, the pressure of water increases. Pressure exerted by water increases. Because of that, water is pushed out with a higher pressure from the holes at the lower levels. So they come out faster as well as they travel a more horizontal distance. But the pressure exerted at the higher level of water, where the depth is less, the pressure is less. So that is why water is pushed out with less pressure. So they come out with lesser speed as well as they travel a shorter horizontal distance. So I am sure you all can understand that now. So from all these three activities, what are the conclusions we came to? First we said water or liquids exert pressure in all directions. Then the pressure exerted by liquids at the same level is the same or equal. Then the third one, the pressure exerted by liquids increases with the increase in depth of the liquid column. So we have come to three conclusions. After this, we will look at another activity where we try to demonstrate that the pressure exerted by liquids only depends on the depth or the height of the liquid column, but not the shape of the container or the amount of liquid inside that container. So that is going to be our next activity. So with that, students, I will move on to the next slide. So as I told you, another activity, here we are going to observe the dependence of liquid pressure on the shape of the water column. So we have to demonstrate and show that it doesn't depend on the shape of the liquid column or the water column. Again, the required materials. Now look at the diagram, students. There are different containers or different columns, we can say, with different shapes. So that's the thing. Now you don't have to find containers with the same shapes. It just has to be different shapes. So you need to have 5 containers with different shapes. That is, so we need 5. Say this one you can see at the top, it's broad, towards the bottom it's very, very thin. Here, of course, it's a different shape. Here the top is thin, the bottom is broad. Here the shape itself is different. Here it's a uniform diameter but a thin tube. So like that we can take 5 different shapes or at least 3 different shapes. So according to this activity, we will be using these different shapes of containers. Then we need a PVC tube. You know what a PVC tube is. Polyvinyl chloride, the normal PVC pipes. So you need to take a PVC pipe so that you can fix all these containers to the pipe. So if we have the pipe like this, what we will do is, we will need to make small holes and insert each of these containers into those holes. So maybe if we have 5 A, B, C, D and another one E. So like that we will be inserting all these containers. Thereafter we will fill water. Although in the diagram it is shown with water because you have to fill water. So but before doing that you connect it to the PVC tube. So you have the same level at the bottom. Then through one tube if you pour water, you know what will happen. Water will flow through this, but it will fill the PVC pipe first. Then it will start filling all the containers at the same time. Although you pour water through one container, all the containers will fill up simultaneously. And also you will observe the height of the water column. It will also increase gradually but simultaneously in all the containers. So after that what we will do is we will measure the height of the water column in all the different tubes. That is the activity. So let's look at the procedure again. So the method. So as I told you all students, can you all see the setup? Now here we have the PVC tube. Now you can see the holes made there and the containers have been fixed, and also you can see the water has been filled and we have labeled it as A, B, C, D and E. Is that clear? So then if we look at the method again, find 5 transparent tubes. So here it has to be transparent. It's must. So that you can observe the height of the water column and you can measure it. So it has to be transparent tubes having various shapes. That's also important. The shapes have to be different as shown by A, B, C, D and E in figure. So that's the figure given to you. Here also students, if we are doing the activity, it would be better if we can use colored water. So if the water is colored, it is more easier to observe. You can use any color to make it more visible. That's the only reason. Fix them to a PVC tube with closed ends as shown. Fill the system with water. Record the vertical heights. So here you need to record the vertical heights of the water columns in each tube. So what is the vertical height you will be recording? This particular height. This particular height from this level to the surface of water. In all the columns, we will measure the vertical height. But from the diagram itself and from experience, you all can understand students. Will the height be different or same? I am sure you all can understand that the height of the water column in all the containers will be the same. So this is the activity. I will move on to the next slide. So once you do that activity and once you measure the heights, we will say we did the activity and if we measure the height, we will get the same height. So for example, here I will take the height as 10 centimeters. So in this table, you can see the tube label is given here and the vertical height of water column in centimeters is given to you. So let's assume the height of the water column is 10 centimeters in A. In B also it will be 10 centimeters. So even in C it will be 10 centimeters, D 10 centimeters and E also 10 centimeters. So that means from the bottom of the PVC pipe, the height will be the same. I will go back to the slide and explain why. Right. So here, this is the setup that we made. Now we have discussed some of the properties. You all can remember the pressure exerted at the same level of a liquid column is the same. So if we take this PVC pipe, what is the level? Now if you take the bottom surface, it's the same level. Even if you take this surface, it is the same level. So when you have equal heights, we said when the depth of the water column increases or the liquid column increases, the pressure increases. So if we have the same height or same depth, so what do you think the pressure is? It is the same. So you have to understand, students. Now at equal points or at the same level, now these are all the same level. The same level, pressure exerted by water is the same. Then the vertical height is the same. So when the vertical height is the same, pressure exerted by that vertical height, because we have discussed that also. Pressure increases with increase in depth. So when the vertical height or the depth is the same, pressure exerted is going to be the same value. So since the pressure here is same and the vertical height is the same, each column exerts a pressure that is equal. Let's say this column exerts a pressure PA. Students, this is not Pascal. I have written it as subscript. So PA. Or I will make it more clear, I will write it as PA. Then this is PB. Column C will exert a pressure PC. Then PD and PE. So from this, you all can understand, students, the vertical height is the same. So the depth of the water column is the same. When the depth is the same, the pressure exerted will be the same value. And here again, the pressure felt at all these points. Because it is the same level of water, the pressure is going to be the same. What is the difference? The shape of the containers are different. So the shape of the water column is different. And because the shape is different, the amount of water. Now see, in this, there's less amount of water. Here also less compared to these three. But these three from the shape we can't really say, but obviously you can understand the amount of water is different. But that does not affect the pressure. Why? The pressure exerted by this column is PA. That is equal to the pressure exerted by this column, that is PB, by the same level. That is equal to PC exerted by this water column, again equal to PD exerted by the water column D, and that is equal to PE exerted by the water column E. Is that clear to you all? So from this, we can confirm and say or conclude and say that the pressure exerted by a water column depends on the height of the water column only, but not the shape, not the amount of water. Is that clear to you all? So if we have a thin tube like this, if we have a broad tube and a very broad container, but if all their heights are same, if this is H, this is H, and this is H, the height of the water column is the same. You can see the amount of water is less here, more, and very much higher here. Shapes, of course, almost the same. It's like a rectangle shape, but obviously you can understand the amount of water is different. But the pressure exerted here is equal to the pressure exerted at this point and the pressure exerted at this point. Why? The heights are the same. That is the conclusion we can get from this activity. I am sure you all can understand that, students. So I will move on to the next slide and write down the conclusion. So we can say the pressure exerted by the liquid column depends on the height of the liquid column, but it does not depend on the shape of the liquid column or the amount of liquid present. So it does not depend on the shape or the amount of liquid present, but it only depends on the height of the liquid column. Is that clear to you all? So those are the activities, students. I explained with the diagram, then we wrote the conclusion. The pressure exerted by the liquid column depends on the height of the liquid column, but it does not depend on the shape of the liquid column or the amount of liquid present. That is something you all have to remember, students. So from all these 4 activities, we can understand the hydrostatic pressure or the pressure exerted by liquids. What are they? Now, the pressure exerted by the liquid acts in all directions, and it is the same pressure at same levels. It depends on the depth of the liquid column. The pressure depends on the depth of the liquid column. And finally, the pressure depends on the height of the liquid column, but not on the shape of the liquid column or the amount of liquid present inside that container. Is that clear to you all? So, from all these activities and the observations, we can come to the following conclusions. You will notice that the height of the liquid column of each of the tubes is the same. It is clear from the above experiments that the pressure at the equal levels of a liquid is the same. So, pressure at equal levels of the liquid is the same. Therefore, the pressure at the places where all the tubes are fixed to the PVC tube is also equal. The height of the liquid column of each of the tube is being the same. So, we can conclude that the pressure due to a liquid column depends only on the height of the liquid column and not on the amount of liquid or the shape of the liquid column. So, this is what I explained to you all before. I am sure you all can understand that clearly. So, with that, students, I will move on to the next slide. So, according to our study so far on pressure due to a liquid, the liquid pressure has the following characteristics. So, all the characteristics that we observed from the activities. We can say the pressure exerted by a liquid column depends on the depth of the liquid column. And under that we can say the pressure increases with increase in the depth of the liquid column. So you all can remember that, students. The pressure exerted by a liquid column depends on the depth of the liquid column. So this is the activity where we looked at the bottle with holes that were equally spaced. So there you were able to see from the bottom holes the water was pushed out with a higher speed as well as to a longer horizontal distance. Whereas the upper holes, it came out with less speed and to a shorter horizontal distance. That is that activity. Then we can say liquid pressure is the same at the same liquid level. So this is where we had the bottle with holes at the same level. You were able to see the water was pushed out with the same horizontal distance. So the water traveled the same horizontal distance because the pressure at the same level is the same or equal. That is the next one. Then the third one, we can say pressure is the same in all directions at the same level. So not only it is same at the same level, but it is the same in all directions as well. That also you were able to observe with the same activity where we had the holes in the same level. So throughout the holes, around the bottle, the water came out and traveled an equal horizontal distance. So those are three conclusions. The fourth one, the activity we did last with different shapes. So there we can say the pressure exerted by the liquid column depends on the height of the liquid column, but not the shape of the liquid column or the amount of liquid. So those are the characteristics that we observed so far. I will go back and go through the characteristics. So according to our study so far on pressure due to a liquid, the liquid pressure has the following characteristics. What are the characteristics? The pressure exerted by a liquid column depends on the depth of the liquid column. So the pressure increases with the increase in the depth of the liquid column. Then we have the second one, liquid pressure is the same at the same liquid level. And then the third one, pressure is the same in all directions at the same level. And the pressure exerted by the liquid column depends on the height of the liquid column, but not the shape of the liquid column or the amount of liquid present in that. So, is that clear to you all students? I'm sure you all can understand all these characteristics of hydrostatic pressure. So, then we will try to come up with an equation, or we will try to understand the equation used to calculate hydrostatic pressure. So, okay students, now that you all have understood all these characteristics, then as I told you all, we need to understand the equation that is used for pressure exerted by liquids. So, with this, I will end the chapter here, and in the next chapter, I will explain how we come up with the equation for liquid pressure, and thereafter we will do calculations, and then we will discuss transmission of pressure through liquids.